This is the first video for chapter 7, and this is how your notes should look in your notebook. This is how your page should be set up. How do you simplify an expression with integer exponents? So in this lesson, I'm gonna demonstrate how to simplify an expression with integer exponents, but we're gonna learn some new terms and some new properties. I want to remind you that this is section 7-1 out of your Holt textbooks. And we have to first discuss what an integer exponent is. Remember, integer exponents are negative numbers like -3, -2, -1. They can be 0 or 1, 2, and 3. So any ... any negative number, any positive number, and 0 could serve as the exponent. And I'm going to demonstrate how to evaluate expressions with integer exponents. Here is a reminder of what you learned in chapter 1 last semester. X in this expression is the base and 4 is the exponent. The entire expression is called our power. I will be referring to these vocabulary terms throughout the lesson. Here is our first exponent property to learn. What do you think it is? Take a look at all of these expressions and write them all down. Here's one. 3 to the 0 equals 1. 123 to the 0 equals 1. -16 to the 0 equals 1. And 3/7 to the 0 equals 1. So our property is x to the 0 power equals 1, and x can serve as any number or any fraction. So x to the 0 power equals 1. Any number to the 0 power will always equal 1. I thought I'd help you out when you're trying to read math. When you're trying to read math, like 2 to the -4 is read as 2 to the -4th power. So look at these different expressions. And I'd like you to try to guess the power. What is happening whenever you have a number raised to a negative exponent? Take a minute, pause the video, and try to come up with the property. Okay, I'll assume that you paused the video and you tried to guess. So here, I'm going to use terms as unhappy and happy. There was a teacher that I took over for a few years ago, and he used these terms to explain how to make a negative exponent positive. So when an exponent is negative, it is considered unhappy. And notice I have a sad face in red. In order to make it happy, like the blue face, all I have to do is take the base and the exponent and put it in the denominator. When I do that, it turns my exponent happy and makes it positive. So remember, when it's negative, it's sad, right? Anytime you feel negative, you're sad. And when you turn it positive, like here, when you turn it positive, it becomes happy. I meant to write positive, not happy, but that's fine. It's positive and happy. So we're going to use this property to help us evaluate some expressions. Just a reminder, make sure you pause the video and write down these examples, and then replay the video and fill in the blanks. So I'll go ahead and pause for a minute to let you pause the video and write down the examples. Okay, I'll assume that you paused the video, and now I'm going to begin solving these examples that we have here. So let's look at example A. Example A is 4 to the -3rd power. In order to make it happy, because right now it's sad. So then to make it happy, all you do is take the 4 to the 3rd power and I put it in the denominator and it becomes positive. If I have 4 to the 3rd power, I'm going to write 4 3 times in the denominator. Keep the 1 up top. Notice how I keep the 1 up top for my final answer, and 4 to the 3rd power is 64. And I evaluated part A. Example B, any number to the 0 power is equal to 1. So part B is done. And notice I wrote down a step here. Any non-zero number raised to the 0 power is 1. Let's look at part C. I'm going to put -5 in the parentheses because that's how it begins. -5 is going to stay in the parentheses and go to the denominator because I want to make it happy for the exponent. Notice it starts off a negative When I put in the denominator, it becomes a positive exponent. I'm going to write negative 5 4 times. And negative 5 multiplied by itself 4 times is going to give us positive 625. Right? 5 times 5, giving 25. 25 times 5. And then that answer times negative 5 again will give me positive 625. And that's my answer for part C. And for part D, it's a little bit different. Notice there's no parentheses around the negative 5. So I'm going to keep the negative on the outside. And I'm just going to write the 5 to the positive 4 power to make the exponent happy. Now I'm going to write 5 to the 5 4 times. Here we go. And notice I still have my negative here. So it's going to remain negative in my final answer. And then 5 multiplied by itself 4 times is going to give me 625. Look at the difference between C and D. Notice how negative is in the parentheses. My final answer was positive. That's because of the even exponent, 4. And look at D. D ended up being a negative answer, and that's because we had negative without the parentheses. Keep that in mind for further examples. Okay, let's go ahead and recap some of the properties we learned today. Anytime you have 0 to a negative exponent, it's going to be undefined. Oops, undefined. There's no way to get an answer for that. There we go. Undefined. When x is to the 0 power, that means any number to the 0 power, our answer is going to be 1. X to the negative 2 power, well, it's a unhappy exponent. Unhappy. So to make it happy, I'm going to do this. I'm going to put the x squared into the denominator, and it becomes happy. And the last part is actually reverse of what we just been taught. It's in the denominator, and it's unhappy because it has a negative exponent. So to make it happy and have a positive exponent, we're going to take x to the negative 2 power, and now we're going to go in the opposite direction and put it in the numerator. So it becomes x to the squared power. Technically, it's x to the square over 1, but we never write it with the invisible 1 as a denominator. Okay, make sure you have this table down. We're going to recap this example, or the examples we covered in the slide later on. We're also going to do some more difficult examples, so make sure you have these properties memorized and ready to apply in class.